Today, we have John Gallegos, who is currently the CEO for CSTi and has over 26 years of experience in land surveying and construction industry. John is a graduate from University of New Mexico with a bachelor's in civil engineering and construction management. David Acosta is the president of CSTi and has over 20 years of land surveying experience and is a graduate from New Mexico State University with a bachelor's in surveying engineering. David is also a past president of New Mexico Professional Surveyors Association and is also the current NSPS director for New Mexico. So I appreciate you guys jumping on tonight and taking the time and have a great little discussion. And then we actually got you coming back next month as well. So
yeah,
I appreciate you guys' time. So without further ado, I will turn it over to both of you boys.
Yeah. Well, first off, Trent, I want to thank you for the opportunity to be a part of this. Mentoring Mondays, it's a huge deal. I love what you're doing, and I appreciate all the efforts that you're putting into this. We are big about promoting surveying and sharing what we know with everybody, with the public, anybody that wants to learn. Basically, we're real big upon that. John's taught me a ton of stuff, and we just want to keep, that's part of our culture here at CSTi, is to want to share information and learn from other people and kind of live in that environment. So we're great to be here.
Yeah, I appreciate it. Definitely the new way. That's what the way change the culture of the whole survey profession, right? So.
Absolutely. And having a platform like this, it's like I was explaining to some of our interns about Mentoring Mondays, and I told them it's going to be like you walk into a library and there's different books or different lessons that you may want to learn. You go pick the one you want, you pull that book off the shelf, and here you automatically have some resources from some people, and it's not necessarily textbookish, it's from a practical standpoint. So it's a really awesome thing.
Yeah, it's a great analogy.
Yeah.
Awesome.
I think one other comment to kind of complement that introduction and what you said, David, is CSTi is also a leader and looking at future technologies and how it applies to the geospatial world. There are a lot of companies and people out there that are like always Googling, hey, what's the next biggest fix, or what's the next biggest application? And we do a ton of research. We invest a lot of money in our technology and our assets, and we go out there and we test it. We're not afraid to go out there and say, hey, is this going to work for us? Is it going to be the right tool for the job? And we like to advocate for the most efficient and repeatable solution there is out there. The quality of data, quality information is what we always strive for. So it's really important for us to be able to be an arm for that, for someone who doesn't know or doesn't want to invest into something just yet, because we're kind of almost like the guinea pig in a lot of ways, but we test a lot of stuff. And we go through a lot of the heartaches, and David and I always are trying to put YouTube videos out there, because we all know how important it is that you're 3 o'clock in the morning and something happens and you're like, oh, I'm just going to Google it. And, someone out there has a solution to an issue or something, or somebody's doing something. But I think it's important also to be able to sit there and give this platform. And thank you, Trent, for inviting us, and the entire, your entire platform also, but to be able to reach the phone, pick up and call us or email us and ask a question about some of the things we're going to be talking about today. So, we always answer our emails and our phones, and we always look forward to challenging questions. And if we can't if we don't have the solution, we'll definitely, we'll research it and we can find it together.
That's awesome. I love it.
All right. So you could see the screen there. Good.
Yep. You're good to go.
Okay. Awesome. So, we have this title, SUE versus 811. Ultimately, it's just a little bit of a refresher on the SUE process, which stands for Subsurface Utility Engineering. 811 is part of that process. But so there's a little bit of confusion at times about how it all works. Even talking with engineers, and we ask them, do you know, are you familiar with the SUE process? And some will say no, admit it, maybe. Others may shake their head, but as we get into it a little bit more, yes, they understand the idea, but maybe not so much the guts of the process. So we've really focused on utilizing the SUE process to guide us, through doing this investigation. So, we want to be able to share how we follow that process and how that process works, and then towards the end, we're going to dip into a little bit of the newer technologies and also ways that we can use this data for use even beyond just the SUE survey. So that's kind of the gist of what we'll be sharing with you today. So, starting off here, well, why is awareness of utility damage prevention so important? Well, the one that's not written there, that's the first and foremost important, is going to be safety, right? We want to make sure that everybody's staying safe, whether it's the public, whether it's our employees, any utility personnel that are out there excavating or doing utility investigating. We want to make sure that we're creating a safe environment all around. Another major one is going to be, of course, the cost that's associated with these utility strikes, and the numbers are huge. Earlier this year, I came across Geoff Zeiss here on LinkedIn, and I think I might have captured one of his articles through a Google search. But I was really, for those that if you may not be following him already, definitely give him a follow, because he's got a lot of great information that he's sharing. But I got some facts, some numbers from him about what it was actually costing, the US in damage prevention. And we're looking at numbers, national cost of damage to underground utilities in 2019 was $30 billion. And then when you look at the waste and inefficiency of US underground utility prevention systems, that's around 61 billion. So we're trying, but it's not maybe doing the job that it needs to be. And one thing to also consider is that we find that a lot of times these utility surveys are kind of last on the totem pole. They're not even always a necessity to some of our clients and stakeholders. It's almost like, well, if we have enough budget, we'll do that. And definitely we need to flip that way of thinking. This has got to be one of the things that's a non-negotiable here when we're looking at utilities, things that we can't see. We're really excited to get the survey done and everything above ground because we can see it, but a lot of times we're not really paying attention to what's underground, and that's what's really costing a lot of money, not just in fixing things, but also just the time that it takes away from a project that may be already ongoing. So there's a lot of work to be done, but I do see some progress coming where people are being more aware. Of course, that's why we're also happy to be here and any other place that people want to hear about this, because it's all about educating at the end of the day.
And I think the other thing that you also have to recognize is, the information system, the information structure of how all this information is placed together. It wasn't done or built on a survey system, so to speak, or survey quality. GIS, before it got away from surveyors in the early years, is they were just pumping information into the system and wasn't vetting it, wasn't going out there tying it to anything. And a lot of times 811 and also the resources that are associated with 811 and those information systems are just not vetted by a surveyor. So that's why it's kind of important, or really important, to tie this into surveying, because once we go back and reconcile the information, it begins to be able to focus in on the quality of that information, to be able to put in a repeatable life cycle process, so that way everybody can always be able to life cycle that information.
Okay, so moving into the guidelines, the ASCE guidelines. American Society of Civil Engineers is the ASCE. So we've been following their guidelines, and especially when you're looking at the level D, C, B, and A process, and we're going to get into that here and give you a refresher on that. But it's basically laying out how these rules are going to be. One thing that I did find pretty funny about looking at this document is that it does have the word survey in there 25 times. I counted them. So I'm convinced that we need a surveyor is going to be pretty key in this process, and maybe that's why not as many engineers are familiar with it, because it's kind of a survey thing. And me and John always have the discussion about how, utilities might be brought into more of the survey world and being thought of as an actual survey. I mean, we are making 3D measurements at the end of the day with our survey grade accuracies, and, looking at maybe a particular flavor of surveying that is specified as utility surveying, and maybe we'd be able to adapt some of these rules, or at least meet halfway to have a great understanding between the two on how we can cooperate with each other, because we're both going to be necessary to this process. So again, a little insert here from Geoff. It's talking about how there's some updates being done. I don't believe they've come out yet, but they're trying to at least consider the technologies that we have now from when the first issue came out. And so there, like I said, there's at least some progress towards us wanting to update these standards for the greater good. We're going to take what we've learned, we're going to take the technology we have available to us today, and we're going to, make it a better process that people want to follow and understand. So when we look at the SUE process, we have levels D, C, B, and A. And the way this works is it's basically a buildup on itself. You're starting from scratch. You're kind of digging. It's an investigation that we're doing here. A lot of times me and John have compared this process similar to doing a boundary survey, where you're going to go out, do some research. You're going to go out into the field, collect some points, bring it into CAD, maybe doing a little bit more research if necessary. You're going to look through your data, go back out, do another search, and before you know it, you start to come up with a solution. So it's sort of similar in that nature. When we get to level A, we're actually finding test holes. That good feeling you get is very similar to finding a survey monument when you've done your due diligence and it's there, and you stick the shovel in the ground and you feel it there. It's a similar feeling that you get. So maybe that's what's really enticed us about this. So level D, records research. We're reaching out to utility companies, anybody really that has any information. It could be, personnel from a certain entity. And so with that, they may have been a part of some of these utility installations, so they're familiar with where they are and can actually physically point and say, it's got to be around right here somewhere. So we take that information, we go out and survey, and that's going to move in on to level C. We go out and survey certain features such as manholes, water valves, fire hydrants, etc., and we start to correlate the two. And then the next process would be level B, and that's where we get our ground penetrating radar or our radio detection methods, and we take everything we've gotten from level D and C and start to mark the utilities on the ground surface using those tools. And usually at that point, we're going to pass it to the engineer. They're going to look at their designs and come up with some sort of conflict analysis. And then typically they're going to order the test holes. And that's where we actually are going to dig. So just to expand on that a little bit, and I'll let John, why don't you talk a little bit more about records research and how important that is. Oh, I think you're muted, John, sorry.
My apologies.
There you go.
This is one of the most important processes, and my mapping background goes a pretty long ways. We used to use Leroy lettering back in the day, but I always used to see these piles of maps that used to sit in some person's corner, and whether it's a surveyor or it's a facility person. And I was always curious, well, hey, let me go dig in that pile or this pile. It was like unboxing a present or, finding a treasure. But recently this is just simply doing your diligence in terms of research, going out there, knocking on doors, being able to go in there and just talk to people, buy a person a cup of coffee or something like that. Say, hey, do you ever remember installing this line? It's a lot of the same process as you being able to do a boundary research, boundary retracement through parole evidence and some of the other things. But this is one of the most, it's beginning stages of the information. So that way they give you the oral recollection, because a lot of times the ones that know where they install this are getting ready to retire or have like those maps that aren't digitized, or they sit somewhere, and whether we don't know at this point whether the information is accurate or it's installed or it's abandoned or anything like. We're just happy just to get our hands on something. So the diligence part of this is just the most important step, but it's also the broadest in terms of the quality of information, because anybody can draw a line on a map, but actually going out there and physically retracing that and being able to put pen to paper and some other stuff to be able to put all the evidence together is that it starts going to the process. So again, don't be afraid to go out there and talk to people. It's just like anything else, talking to neighbors, whether feuding over a property line, talking to utility companies is kind of the same way. You're gathering all that in this information and you're putting it into a database, and then you'll be able to give it to your team member for the next level.
Yeah, and
I got a question on that though, from the research side of things. So like, for us in Las Vegas, only engineers can actually request the information. And so I'm just curious, like what kind of hurdles you guys have kind of ran into on the research side, like going to these municipalities and they won't, everything's going to an online records request, and, must have an engineer request that stuff. So I'm just wondering what kind of hurdles you guys have hit.
So I'll give you a good example of what we did in the city of Phoenix. Is we set up an account. And it says, well, you have to have an engineer do this and that. But fortunately for us, the workaround for us specifically is that the person that was reading the application, not only do you have to pass a background check to get this information because of Homeland Security things, but when they ask about the engineer, it's kind of more of just persuading them to say, hey, this is what we're doing. We're independent. We're working with an engineering group. And also in our DBE stuff that we're registered with them, it also says that, we're able to, we have sourced engineers, outsourced engineers on our staff to be able to help us out. And, it's just basically finessing that to present it to them. So that way they know that they're giving the information to the right person in the right hands. They just are not educated enough to understand that it's not only the engineer that's part of this process, but it's seen as that if you present yourself as a team member and the application is you're just trying to give them a full idea of what's going on, I think that is mostly impactful and it'll get you where you need to be.
yeah, and it's a lot, again, it's the analogy of records research with plat records, survey records is every county seat may have a little bit of a different process.
Yeah.
I can get free plats here in Doñana County. If I go to Bernalillo County, I got to pay for them. And I can't even see them. I'm buying something I can't even see over there. So again, the coffee thing is good. Take up some donuts. But there is a little bit of frustration sometimes because we, like say in Albuquerque, we would love to just have the GIS database so that we have that. We're using it for protection of these utilities at the end of the day. And I understand the security of it, but if there was something we could do, it would be nice, to have that. So in some cases, some are more willing to provide that information than others. And when somebody inquires with us about about one of these SUV surveys, first thing I do is ask, do you have any maps? Right. And most of the time they're going to say no. And then a lot of times we end up proving them wrong because we'll find a way. We're going to find a way, or just the luck of being out there, you talk to the right person and they got the maps. It just has a way of working where it turns out that way. John, we were working on a project up in Sunland Park area, and John made a site visit, happened to catch one of the facilities personnel, got a business card. Today, I got some beautiful maps in that are really going to help us to, in our investigation. So it's just one of those things,
That's awesome.
So, okay. So moving on to, so part of level D, I have a slide here on 811 because level D 811 is going to be part of the level D side is calling 811, ordering that ticket for the utility owners to go mark out where they think the utilities are. And again, even on this, you're never exactly sure what you might be getting out there and how they're going to be marking those utilities. What type of information or tools are they using to do that? Is where it gets a little bit different from place to place. Let's see, so, but there is a difference between 811 and having a private locator, which we would be considered a private locator. One of the biggies is going to be that 811 is not going to mark utilities on private property unless there's easements or license agreements on there. So, if it's a private property, you may not always be getting that extra layer of search occurring. And, it's calling a private locator is going to add an extra layer of risk management for engineers and utility owners. So, we can, a lot of times, we're going to call 811, and we're going to go out there and we're going to verify what they have marked, and we're going to compare that with any maps that we may have or easements or any sort of that type of information. So, and with that being said, utility owners don't always know the exact location of their utilities. And there's a lot of undocumented utilities out there. And we were working on a project, I think it was last year, where we did a SUV survey and we found a gas line that nobody knew where it was. It wasn't marked by 811, didn't show up on any maps, nobody knew about it, but it ended up really impacting the design because they didn't have a lot of room to begin with. It was a road going up to the mountains. So it kind of, it was valuable information to them, but I'm sure they were frustrated with the situation. But better to have had it occur like that than they get into construction and, oh man, we have a gas line here that nobody even knew about. Secondly, utility owners may know the horizontal location of the utility, but maybe they're not sure of the depth. You have a high pressure gas line, it's there, there's a double line there, but you're not sure of the depth. You're definitely not going to want to be trying to move one of those high pressure gas lines. So it's going to be important to, to have this done prior. And another situation that happened to us is the utility owner, we were consistent with where they had marked it, but they didn't realize that it had a concrete cap or it was encased. So that was going to be impactful to the design. So it was valuable for them to know. So it could be a little bit of everything, right? It's just, at the end of the day, it's an extra layer. It could be considered as some type of insurance that you're paying for that's going to clear you of any of these utility strikes.
And I would also like to point out to that great point, David, is that the industry and utilities is really probably 80% in a reactive mode, because there is so much old infrastructure in there. They do not know how or what's operational, what's abandoned. They don't understand the how valuable the level A through D process is. A lot of times they don't budget for it because they do not know how to utilize that process. In the first part of the design, there are situations with engineers where we said, hey, let us do a case study where we're going to do the process. We'll do all our GPR, all of our level B through D structure. And this is when an engineer had already had a concept designed for a roadway and some retaining walls and stuff. And he said, sure, go ahead and do that. Well, when we presented him with our SUE survey and our topography survey, when they got the information, well, right off the bat in their conceptual design, there was no way the wall was going to work because there was fiber optic lines and there was a bunch of things in the way. So they had to kind of like rewire the way they were thinking with this information up front, because they didn't realize how valuable it was to have it before in the early stage of the design. And that impacted the project where they had to scrap and reinitialize another concept of design because they had that information. But then they realized that had that happened in construction and they were going to put that wall, it would have tanked the project because how expensive it would have been to move the fiber optic line. So we're dealing with a situation where we're trying to turn the pendulum a little bit to the side of, hey, let's do some diligence at the beginning. Let's put some money into this. Let's get quality of information. Colorado right now has a lot of good legislation where they utilize, they have to have a full SUE survey of a site with all these test holes and everything before they even start the design. So that way they have something that they have a great foundation of information to be able to hang their design on. It's not that we're going through there and we're eliminating 100% of the line strikes, is we're reducing the amount of risk that's associated with those line strikes by utilizing this process to do that. And the only way to do that is to be at the beginning end of the stages of the planning of these projects and how important that information is in the beginning.
Yeah, and that's a good point, John. It's not saying, oh, I'm going to show up on your site and you're going to have zero. We're going to cover you 100%, right? It's reducing, it's managing that risk at the end of the day is what we're doing. And when we're looking at billions of dollars at stake, you can reduce that risk even by 50%. Holy cow, that's a lot of money being saved.
And contractors are our best friend because of this process, because they get paid on change orders. So, it's kind of changing the business model a little bit for the industry.
Right. So getting back to the level D through A process is, coming back to level C, which is where we're going to take all the information that we've gotten up to this point with the D, and we start to go survey the futures, such as the manholes, and we end up creating a drawing that you kind of see there in the middle with a bunch of utilities. And in fact, I have another slide. I don't have it here, but it has the new building that was going to be going in this parking lot. It pretty much took up the whole parking lot. So right away, by overlaying that on there, you were already able to see the conflicts that were going to happen. And it turned out to be a pretty good tool. Moving on to level B. So this is where we do the marks on the ground surface, usually using paint or some kind of marking paint. We use ground penetrating radar, GPR, and also radio detection methods. So, just to the right, the slide on the right is a little screenshot of what the tomography looks like when you go over utility pipes. A lot of people are always curious as to what are you seeing in that screen there? What does that look like? And I think a lot of times they might think we're going to see like a really clear picture of the pipe or something. So it kind of throws them off a little bit when I show them some of this tomography. And so, it looked, when we first started this, I always thought it looked a little bit weird to me too. Is learning like a different language really is learning the tomography. And the advice that was given to me was it takes time. You gotta do it. And the more you do it, the better you get at reading those hyperbolas is what they call them. And being able to have them tell you a lot of what's going on there. One thing about GPR, and we'll get into this in a little bit though, is GPR itself is also not a silver bullet. It doesn't always work, but then again, it does work. So, it's been a good tool for us, but it's definitely not a silver bullet. We do have a lot of redundancy in the tools, and I'll get into that as well here a little bit later. But that's kind of how we do our level B process. We're going to mark everything on the ground and then be able to go map it.
And a lot of times you may not get, because you're dealing with the laws of physics and electromagnetic waves in the ground, is you may not get beautiful little hyperbolas. You have to look for density changes in the natural geophysical layers of the earth. So you have a PVC or vitrified clay pipes that are in the ground that they'd love just to absorb that signal, or they don't have a good reflection because we're limited by the FCC in terms of what frequencies we can use. And of course, the longer the wave, the deeper it goes, but the smaller targets you're not going to hit. So there's always a balance there's always a sweet spot that you have to go in there, and it's a tool for a job and a process of redundancy. And this is one of the tools that's in the toolboxes. So that's one way to describe it. So, and GPR is great, like David said, sometimes, but sometimes it could give you problems, and then you'll have to pull out the old witching sticks, which is, I don't think they have a level for that one. That's sometimes that works better than all of them combined. Or dowsing rods, sorry, dowsing rods. I think that's correct, but the pseudoscience.
Yeah. So usually, like I said, at this point, we're turning over data over to the engineering group, and they're going to do their conflict analysis and throw their design in there and start to understand what kind of conflicts might happen. And then they're going to order the test holes. And this is, we call this survey CrossFit, because digging test holes is definitely a physical job. And anybody that may be listening that's ever done it was probably shaking their head in confirmation. It's not your typical survey type of activity going on. We're dealing with vacuum trucks and high pressure water, high pressure air, a big concern for safety. We're in the road. There's a lot going on. Sometimes we got to get barricade permits and all kinds of stuff to do these test holes. And it's a lot of work that goes into them. And one thing that bugs us more than anything, just as our group of people here, is when we have a miss, right? There's nothing worse than digging this hole and all this work and there's a miss. So we really try to go above and beyond before we excavate, to know that we've had a redundancy in information to get us to make sure that before we start digging, we have a lot of confidence in knowing that there's going to be something there. And so we pride ourselves on our hit rate, on the fact that we can, most of the time we're hitting utilities. There are some misses that happen sometimes, but we overall, we have a pretty good hit rate. And like I said, it's like comparing it to a boundary survey. You do all this work, you dig a hole, you get a signal, you keep digging. People tell you're crazy, but you keep digging, and sure enough, there it is. And instead we're probing a rod into the ground, right? It's like looking for something that you can't see, like you're reaching behind your car seat and there's something there, you can't see it. It's reaching, and then you get that, you start to feel it there, and you think it might be it, and you kind of give that face to everybody, like, I think I might get something. And then you start to wash it, and you're sucking up the dirt, and you start looking at it, you shine the light in there, and when you see this utility, yes, we did it. It's a good feeling. It all came together, everything from the beginning. This whole process comes, and here we are. So it's really a cool thing.
And I think it's important to point out too, and when 811 places markings on the ground here in New Mexico, the buffer of accuracy is plus or minus 18 inches from the center of their mark. So you have a 3-foot window. So if you're in the middle of a street and you got to dig a pothole the size of about 10 inches, and you're plus or minus 3 feet, that's a 3-foot patch you got to put in the ground, and you got to take the soil out and put it back and compact it. So that's why it's important that the quality information that you're starting from D all the way through A, and why it's important to initiate these processes and have a good hit rate.
Yeah, and there's no other way to be able to tell the exact size, type, without physically seeing it. Up until that point, we're using these tools to make those assumptions, but we won't truly know until we've dug the test hole. Whoops. So when we were working on this, it made me think about the accuracy and precision diagram that we had back in school. You have a mark on the ground, and typically it could be 811, it could be anybody. The survey crew doing a design topo is going to go over there, see that mark, shoot it right in the middle of the mark, and take it back to the computer. The engineer may think, oh, this is survey grade information. Where they shot it at is the true location of where this utility is. Let's go ahead and do some design. But in fact, that's probably not the case. there's going to be a little buffer even within the rules of that. It's going to be a little bit here, a little bit there. But I think a lot of times that isn't understood by somebody doing the design, and they think, oh, it's okay, let's move forward, it's good. And come to find out, they go to tie-in and we're having utility strikes. Tie-in points are where they think they are. So it's really messing up the design. But when we can have this here, then that's when accuracy and precision line up. If I can physically put my rod on the top of that pipe, accuracy and precision, or if I can make a reference mark above ground that has a direct measurement to that, we have accuracy and precision. Now we're really surveying. See, to me, this is surveying right here. We're lining up everything. It's not just an idea, not just an assumption, but here it is, some good hard information.
Going back to, I like Josh's comment on that thing, reminding, that you're just marking out a signal, right? And so going back to John's point, it's plus or minus, they have plus or minus 18 inches, but again, it's no signal, it's no different than our metal detector, right? We're coming across all kinds of different signals, and you just never know where to start digging, I guess, right? So
yeah. And I think most surveyors, they're going to go capture what's there. That's their job. They're not, I think for the most part, they're not thinking about the underground. They're just showing it as it is. And it could be misinterpreted once it comes into the design phase if things aren't careful.
Yeah, for sure.
I think another good thing to add to that, is pay attention to these 811 locators. A lot of times they don't have an instrument in their hand. All they're doing is accurately marking the same mark that they placed on the ground with flags and all of that. It's like, how do you know that that's not over here? Or how can you tell them, hey, I actually found the utility like 4 feet over here? How are you able to convey that message to them? And again, that it just goes down to the fact that, putting paint on the ground is different from actually doing your diligence and using the equipment and placing the records together. And a lot of times what we do too is we'll dig these holes. The reference marks also serve, because we always put reference marks in line with the utilities. That serves as a point of awareness. So when somebody comes behind us and 811's out there and they're going to be, oh my God, the gas line was over here, but wait a minute, there's a pothole right here, or a test hole or keyhole. Well, I better move my line over now because now it's 18 inches in this spot, but we don't know what it's doing another 100 feet down the line, so to speak. So we are essentially creating additional awareness by putting those reference marks on the ground. And sometimes we even, in areas where we have performed such hard tasks locating these lines, finding PVC water lines in the middle of Jal, New Mexico, nobody had any records, is we'll go and we'll put some PVCs and we'll paint them blue, or we have some carcinate markers or something. So that way, someone that comes behind us is always retracing our steps. It's kind of like the survey motto. We're always following the footsteps of the previous person. Utility should be the same way. And we're always advocating for that role because it's important, because it's a retracement and you're leaving the breadcrumbs for the next person that's following your SUE survey.
Yeah.
Do you later on in your presentation, do you get into liabilities or anything like that? Or is that something we can talk about again? I'm just thinking, you're just throwing darts at a dartboard. Where the heck's the liability when it comes to some of this? But
right.
Talk about it afterwards. Yeah.
Yeah. Did you want to cover some of these chat comments or at the end, or?
Yeah, I think you got a couple of them that have, we can go back to Glenn. Glenn was kind of on the 811. He was asking, how do you do a records request, a records only request? I think you kind of answered Sean's, because he was talking about GPR. What's better way, GPR or that, which we kind of hit on why the markings don't hit the everything. So maybe you can hit.
I could answer Glenn's question real quick.
Yeah.
A lot of times when you initiate what they call design locate tickets, they're not going to go out there and mark it. If there's a ton of stuff they're going to do, they're going to say, hey, I'm just going to give you the same map that I go out there and walk in the field with and put paint on the ground. So it's like, it's the law. They're supposed to go out there and do it. But we have done this so long that it's just, some places it's really good and some places it's really bad. So we have to have a connection between 811. We have to have a connection with all the locators, the actually outsourced locators that they use, which is UCISC, I believe. And we also have to have a connection with the Pipelines Safety Bureau, because they're the enforcers of all of this process, and they enforce the law. And a lot of times is that it could be a lot of different things. What's going on is maybe they don't have resources, maybe they just don't have quality information. It could be a combination of everything or nothing. So at the end of the day, the diligence is in the request. It's constant phone calls. It's going back and forth with those three systems. But what I don't like about that system is there's no way for us to be able to give feedback to their system saying, hey, I have a great WGS 84 position that's better than your locate ticket. Do you want that information? Well, we have no way to be able to reciprocate that back to them. So there's holes, and there should be things that can be done to refine that process.
Yeah, John, if I could interject just a little bit here. Thank you for that answer. But what I was getting at is that I'm only looking for quality level D, record only. So I want to know what utilities are affected within the project limit. So I submit an 811 ticket, but I try to tell them, look, this is design only at this point. I don't need field markings. But 811 seems to be adamant that no, what we do is field marking. And now, do you want your utilities marked? And the answer is no, but I would like to know what utilities are involved. And then I'll set up a design conference, hoping that either online or on site. But who shows up to these things are the actual locators. And I say, well, this is just for design purposes only. And they say, well, we don't have that information. We can show you where it is on the ground, which is great, but we're not at that stage in the process yet. So that's what I was getting at. And I think what you said earlier was that you're interacting more directly with the utility owners and getting records from them rather than going through the 811 process.
Yeah,
Okay. Occasionally though, we will get, like John said, it's probably the backwards for us where we're like, I mean, I'll take some maps, better than nothing, but we're working more on the ground. And sometimes we have the opposite problem. It's like, here, I'll send you some maps. We don't want to put anything on the ground. It's too big. We'll just send you some maps. And, we're happy to get anything, but I feel like it's these utility owners, representatives that are going out there. They're unfortunately, they're going to be limited to their training or their funds that they have available to do all this types of stuff too. So that's probably why we see where it's a little bit more effective in some places than others, or utility owners themselves that have a little bit better way of how they work with the 811 system. So a lot of times you're just not sure what you're going to get.
If they could give us just a screenshot of their fancy little GIS that they use, I mean, that would be pretty nice also. It would be a lot more than what I currently have, but for some reason they just don't want to give us access to that information, because maybe it's risks and liability on their end that they don't want to be able to take upon, that they're like, hey, we're just going to put marks out here because that's the limit. We're going to give you a buffer of liability, as opposed for them giving you an actual map that has a logo or something that you can come back and say, well, you told me this is where they're at. So I kind of think that there is a lot going on there in terms of what they're trying to represent that information as.
Yeah, and I was just reading Joshua's message too, and that's great, man. I'm gonna take that. That's a great idea. That's what you got to do. We got to get in there, be aware, create those relationships, understanding people, and so that's definitely the way to go. Especially you're working in a certain area quite a bit. Yeah, you better darn make good friends with those people, because they're gonna help you. So that's a great comment. And we've for George's comment, we've had to tell them that we were gonna dig sometimes just to get them to go out there and market. We just have to say it's a dig locate, because otherwise we don't get anything, and it makes it pretty tough. Okay, so jumping back into it here, that's pretty much where the SUE portion kind of stops, right? But we like I said, there's a lot of money being thrown into these test holes for it just to be a one-off type use. why not make better valuable with this information and more value for your clients and owners and stakeholders? So what we like to do is use a platform, some sort of GIS platform. One of the ones that we use is Fulcrum. We've also been using Pointman lately, and then also the ArcMaps GIS platform as well. They're all very similar, but at the end of the day, what we're doing is we're utilizing our technology. We're going to utilize our phones or our tablets or whatever, and we're going to capture this information out in the field, be able to type in the metadata of what everything is, pipe sizes, depths, types, directions, and then we can also take some photos, as you see here on the right, of what we're seeing if we pop a manhole or perform a test hole excavation. So a lot of our clients have been liking to be able to use this data, this map that could be an interactive tool for them. So in addition to just providing some survey shots in a DWG, we like using this GIS platform for them to use in-house. And we can provide an account for them to be able to use. And also we can customize a GIS input sheet for a certain client. If they have, a database that's got to read a certain way, we can do that. Otherwise, we're able to have this information in a tabular format where it can be plugged into a GIS down the road for any other, plugged in anywhere. And for those GIS programmers that really, really know their stuff, they can basically take, two data sets and be able to converge them and make them work together. And that's the beauty of what it is. I mean, being able to recall this information at a later time is going to be valuable. Right after we've done it, of course, it's not a big deal, but when they're going to start to do some more work in this area, why wouldn't you want to be able to go back to this information? And it's not in somebody's desk on a piece of paper or rolled up in the corner of their office. It's in a digital format that we can use and be able to archive and use, for a long time.
I think one of the great things about this tool also, Dave, didn't mean to cut you off.
Yeah, no, it's okay. No.
One of the great things about this tool is that we have engineers always calling us, even 6 months down the line. They use this as a coordination tool with the owners to be able to go and say, hey, picture is 1,000 words. They go back and they're looking, how was the quality of that manhole? It's a redundancy in terms of the process, but it also gives in-depth information for the engineer to go back and look at that moment in time, that condition, the quality, what it was at that time period. And it helps tremendously for indexing and be able to quantify your information and data. And it's so customizable and you can present it in so many different ways, but they love the formatting and how they're able to sit there and be able to access the information. And they always forever are asking for access for information that could be as old as a year. So it's there forever in the cloud. It could be recalled anywhere. And that the convenience is what they're paying for. And that's what they want.
Yeah. And the terminology I always heard with GIS is crappy data in, crappy data out, right? But here we are plugging in some really amazing data into this database that's better than just level B, C, or D. This is level A information that we're plugging into here. This is hard, concrete data. So, we even, for our reference marks, we set a survey cap next to it, or a PK Nell washer, so that we can identify it's there. Somebody down the road 5 years can stake out that point and go, oh, here's that test hole. Oh, wow, look, here's the reference mark. Here it is. So I think it was last year I was out playing golf there in California. It was like a little 3-part course, the executive course or whatever. It was really nice. And I saw this electric line go by. I saw what I thought was a survey monument on the asphalt there. And I went, got a closer look, and it was actually an angle point and in a big electric line that was going to a transformer. And I was like, man, that is awesome right there. Imagine if we treated these assets, these utilities, like we did the property, and we had it monumented. And anytime anybody came on this side, it'd be like a centerline monument. Anytime anybody comes to this site, you pull up that record information, you did your your boundary search, you did your utility search, and guess what? Everybody's sharing that data. Everybody can go refer to that. You could even be a nice guy and put some state plane coordinates on there for somebody to go tie into or something, however you want. Like John said, it's leaving information for the footsteps for the people that are going to be following behind us, and being able to leverage GIS and this tool that I'm going to have in my pocket anyways, and being able to plug in some great information.
Because something is better than nothing in a lot of ways.
Yeah. So we look at this data life cycle here. We got a new project. The design survey and the SUE is ordered. And then the design goes into design phase. We have a double arrow here because sometimes there could stuff that could happen and we have to go back to SUE or back to design. But then the design's completed, goes into construction. We do the as-builts. And here, this is a key one because the request in the as-built has to be proper. Otherwise, if it just says as-built survey, what the heck is that? Why not be more descriptive on what you want out of the as-built survey? Could even be utility as-built survey. So that as-built data, it can be moved into some sort of database that's managed through the continuation and the life cycle of that site or building. Things could be changed, you know, before something really major takes place. But then we go into the new project. So all it is a regurgitation of this information on a site and this life cycle. So the more we can get better at, at archiving, cataloging this information, what's being done in between projects, we're going to be starting projects in a lot better place than just starting with nothing at all. So, you know, we want to encourage people to consider this and our clients so that, you know, we're making better use of funds that are coming to these projects, and it just makes more sense to us.
Because even when we're moving into the virtual platform, the next biggest commodity in terms of value is data management. We need good quality data management because at some point, the PDF plans, the hard plans is going to be a thing of the past. Everything is going to have to get to a point in life where everything is being built and designed in a BIM environment, in a sandbox. It's going to be modeled. You're going to have pipes, three-dimensional pipes. You're going to have design in 3 dimensions, and you're going to have tied to survey databases. That's going to have this huge ecosystem that's going to be tied to, and they already build buildings virtually, and they're going to do the same with the public infrastructure because that's where we're headed, and that's why it's been so important to have great data that's tied to a survey system.
Yep, and I have a slide for that here in a little bit too. But that's what it is. It's great data in, great data out is what we're trying to achieve. So John kind of mentioned here a little bit lifecycle data management, how Colorado Department of Transportation is using the PointMan software to be able to do this, and that's a part of their requirements over there that they've implemented. Let's see. Yeah, so they've it's part of their requirements, and you know, I've reached out to NMDOT a little bit as well to see, you know, how we can get something like this going here, because it just puts a little bit more attention to the utilities and creating a system for everybody to understand and operate under. And it's not just how I think it should be or how you think it should be or whatever. There's actually a little bit more structure when it comes to utilities, and I think that's going to be important for these states to implement, because it's just all about education and awareness, even when it comes to utilities. And again, being able to leverage the technology that's available to us today, why wouldn't we be doing it? So again, you know, developing the database. This was some stuff for New Mexico State, and we were talking about, you know, mapping the whole campus, and whoa, the whole campus, that's a huge undertaking. That's probably not a great idea to go attack all at once. But what we can do is look at areas where people are going to be working. Let's look at the master plan. Where are we going to be operating under, and how can we start to narrow it down there? It was kind of idea for a lot of municipalities that want to start to implement utilizing this, because it's a huge undertaking, especially with bigger cities. John mentioned a little bit about BIM. BIM is going to probably be a Mentoring Mondays topic all in itself, but it's a pretty cool. It's using the same idea of from design to asset management, facilities management, and all the way back into construction. It's a great process that can be followed in order to achieve that. And it's a cool thing. So if you've never heard of BIM, I recommend you to definitely investigate it. Okay, just to talk a little bit about the technology. I think we have like a few slides left here, but CSTi, we really love technology. We're always wanting to get the latest and greatest that we can have available to us. It's just kind of what we like doing. So here down at the bottom, you can see a few of the GPR receivers that we have that are all GPS integrated, and that is GPR with GPS. When my friend first told me about GPR, I thought he was saying, he's like, you should try GPR. And I'm like, GPS? He's like, you mean, he's like, no, GPR. And I'm like, what is that? And, oh yeah, no, you can use it to look for voids and all this stuff. They use it out here in Texas a lot. And me and John had already been asked enough times, about utility locating, that we thought, what, let's give it a shot. And so we rented our first GPR system, and it was delivered to the office, and we pulled it out there, and we were like, what the heck is this thing? And it just did not look like a survey tool or anything we were familiar with. And we went out to go find some utilities that day. I was looking for a high pressure water line, which is, from my experience, one of the more difficult things to find. And I'm so frustrated. I'm turning red a little bit because the contractor's looking at me like, hey man, I thought you said you could mark utilities here. And I called the guy that rented us the GPR, and hey, what's up, man? Hey, I'm having difficulties out here. I don't know what's going on, and this thing's just not working. And he's like, well, man, GPR is just one of many tools that you need. You probably need about 9 or 10 tools to be able to cover everything. And I'm like, man, that's not what you told us when we were going to rent this thing. So I regrouped for the day, went back to the hotel room, and me and my technician were, having a beer, looking at some YouTubes, trying to figure out some more about GPR. And we ended up watching a YouTube video. It wasn't even in English, but it was enough for us to get a little bit better of an idea. We went out the next morning with some fresh eyes and everything. First thing we did was get a hyperbola, our first one. There it is. We were so excited about it, and that was kind of like the start of it all. We started to get into it more and more and more. And so from that day to having what we have now, where we do have, hey, Ruben, we do have GPS and GPR now put together here. So it's a cool tool that has been good to us. And we do have various ones, because there's various surface types, like you see there on the left. That's the 4Light. That one's a little bit easier to go off-roading in, just because of the design of it. And then on the right, you have the Stream C. That one's going to be dual polarized. So when you're pushing it in one direction, it's actually capturing data in both directions. And then with the GPS integration, it's cool on there because it's all going to be geo-referenced when you plug the data into the software and putting it into design drawings. Everything survey grade, geo-referenced information. So it's a really cool combination of tools to put together to do what we like to call is our utility survey, because we're using survey tools. We talked about the redundancy with our tools. And so we're talking about using GPR, electromagnetic detection, radio detection, all materials locator. That's the tool that they're using on the bottom left. It kind of looks like a paintbrush, but it's been effective for us as well. CCTV is another tool that's commonly used. And then also the dowsing rods that we talked about. And dowsing rods, this is always a fun subject, to talk about, because some believe in it, some don't. I don't know why, but recently it just hasn't really been working for me. I don't know if I'm thinking about it too much or what, but John gets them in his hand and they just happen to work better for him. And one day we were standing there with a guy that's a physicist, right? What was Carrie's friend? A physicist, right?
He's an archaeologist.
Archaeologist, but he was doing some crazy stuff with those dowsing rods. He would call out your name and then it would move to you. And he'd be like, John, and it would move over there. David, it'd move over here. And it was just kind of funny. But there are some cool tricks I've seen where, you're holding the rods out, and when you go over the utility, they move in, right? They move in like this. And when you walk away, they move out. So, you're over some sort of object under the ground when they're like this. Then I've seen people stomp their foot and then the things go out like this and then they come back. And however many seconds that took is however many feet underground it is, right?
Yep.
Something like that. So it's like what? It's like one of those field things. It's a pseudoscience, right? But I've seen a lot of people doing it, and anybody that's used it here that's listening, I'd be curious to know some of your experiences. But again, at the end of the day, it's all about the redundancy. We're not putting all our faith in just one of our tools. We want to cover it as much as we can, especially if we're going to be doing test holes, because like I said, last thing we want to do is be having a bunch of misses.
And I would like to point out, Dave, these job sites that these guys are doing this is in an area with the most difficult field and soil conditions ever known to man. There was bedrock, there was all ferrous basalt, there was clays, there was so much, there was cell towers everywhere. So it was so challenging, but these guys did an amazing job. And if I'm not mistaken, I think our hit rate was probably around 95% when all was said and done. And that was, I think, more persistence than it was anything else in their reporting, but they did a great job. But again, dowsing rods and that sometimes that's the one that gets you the $5 copper, and they have to be copper, by the way, but you can do pin flags if you're in a pinch.
Yeah. So just since we're talking about tools and technology and GPR, there are some GPR misconceptions, like I mentioned earlier, that it's not a silver bullet, it doesn't work every time. How accurate is GPR is the question we get a lot. And so it's a loaded question when somebody asks you that. When anybody asks you any of those questions that we're looking at there, the last three, it's a loaded question, because we live in the desert here. There's a little more sand, there's a little more air in the soil. So we might be a little bit more successful with it here. So there's just a lot of, and John, maybe why don't you speak on that a little bit about what
Yeah, it all boils down to soil condition and application. You have to do your diligence in terms of looking at how you have to do a sample size in the area in order to be able to know what the expectation is, because you don't want to create a false sense of persona in the industry by saying, or oversell GPR is to sit there and say, yeah, oh, it works in soils and all this and that. Yes, there's a lot of things you can do, but there's a lot of post-processing, a lot of different things that you have to do to apply to that condition. But a lot of times it just simply, you cannot get there. It has a limitation. And it is a loaded question because it's the same. The best analogy is when you go to the doctor and you get an x-ray and they have records of what the human anatomy looks like, they're going to sit there and look at a normal one. They're going to look at yours, and they're going to sit there and they're going to look for anything that's different. Well, the doctor can't tell you anything more than the testing he got from the blood or the x-ray. He has to initiate another process to go in there to do additional testing in order to be able to make an informed decision. So that's kind of how GPR works, is it's giving you one sense of a dimension of information to be able to get to the next step of what needs to happen next, to be able to sit there and say what a lot of times you're not eliminating, you're not finding targets, or you're eliminating targets. You're trying to sit there and you're trying to just rule out checklist items of what it is and what it's not. And that's a great way to put it. It's like going to the x-ray, getting an x-ray at the doctor and be able to apply that. He's not going to give you the cure based on an x-ray. You have to do a bunch of different things. So that's the lower version of being able to sit there, the layman's version of being able to give a person an informed decision about how that is. But there's a lot to it. That question is, there's a checklist, a huge checklist you have to go through to even answer that question to see if it's going to work on your site or not.
Yeah. And here's a cool, in the picture, this is what's called the Stream EM. This GPR sensor is really awesome. How many channels is it, John? 24?
No, that one has 122 channels in the horizontal and the vertical position. So it roughly, it's a width of about 12 feet. So you're getting, you have two different frequencies. You have a 200 and a 400. So 200 is going to give you the deeper, and the 400 is capturing anything within the 48-inch range.
So
So you're able, yeah. So you're able to cycle between both datas, right? You want to go for the deeper stuff. You have both channels. So it's kind of like the difference between going between, I can't think of a good one. It's like going between the GPR and the total station data sets. You know, they have their application of being able to get you what you want as far as interpretation.
Yeah, but pretty cool because we could pull it with a vehicle or the buggy here. And again, it is also GPS enabled. So when we put this information into the softwares, it can all fall right where it needs to be. Just one last thought on GPR is, I think from a surveyor starting out, being a survey before a SUE surveyor, I guess you could say, is everything's always got to be checked, and it cancels out, or it's checked and it's zeroed out. And that's how we operate. We do that. We start with a check shot, we end with a check shot. We start with our backside, we end with our backside, or whatever it may be. But in GPR, there's just, you have to learn to open up a little bit from that, because things may not be as clear and concise as you're used to when you're doing your checks. I can go out there and I know my controls type because I can physically go check it. And so with GPR, you know, you're just, you got to open up your mind a little bit.
Dave, I got a pretty good example real quick, if you'd like me to show you guys of how GPR can apply and what it looks like with and without GPR real quick.
Yeah, absolutely.
So, oops, I gave you the one. So this is just putting records together. You got the typical grid is sewer, fiber optic.
Wait, is it,
overhead.
are you sharing
This
it?
is- Yeah, I thought I am. See,
Let's see.
Let me stop mine. real
Oh,
quick.
yeah. Okay. Yeah.
Okay,
yeah.
there you go.
Okay.
okay. So this is a project in Albuquerque, 12th and Sawmill area. And you see some water, you see the water, you see the sewer, you see the fiber optic, and this is all a combinations of C and D data. Okay, so the next step is okay, well, let's go out there and kind of do the blind taste test, and let's get our GPR out there and have him just do what we call interpretations, just looking for all the obvious stuff, all the obvious pipes and all of that. And at the end of the day, when we extracted that, the magenta lines are the lines that he was able to look at. So you can see that there's a considerable amount of utilities in there with the GPR that they would have never found just to the record. So again, there's without, and here's with.
So those are all the anomalies, right?
Right, because we don't know what they are, right? They have, these are patterns that they have. They could mimic a utility. We don't know if it's abandoned or not, but we know that there are some that line up with some of the stuff that's underground, like, you know, some of the water. It says, oh yeah, that looks pretty good. That's a level B, so that's designated as the correct location of the water. Because again, we're going from a C to a B in the terms of quality information, so we know that's where it's at. So that's the benefit of GPR, is that it's an independent redundancy check outside of the records to be able to go in there and overlay this data that's survey grade, to be able to look at what's good and what's not, and be able to give the engineer the ability to go in there and ask the questions like, well, what happens if I install a sewer? Well, obviously you have a bunch of stuff in here. You're not going to dig every single one of these, but you're going to pick out the ones that match the records. But at the end of the day, you have to also understand if they give the contractor this map that has, hey, we did a GPR survey and look at we had the, well, you're kind of pushing the liability on the contractor to, you know, dig with the shovel through here because there's a lot of stuff. And at the end of the day, that's what you're trying to do, is you're just trying to create awareness and let them know that there's more than meets the eye than underground, because at this point, you just, it's better than what this would have been, and who knows what all this other stuff would have been, and it would have been catastrophic. And plus, it's time is money, right? You would have messed up the schedule because they didn't have this information in the initial design.
Okay.
Yeah, certainly creates a buyer beware situation there, huh? Yeah.
Okay, let me share here again. Okay. So here's some examples of some tomography, and then also an example of how it looks in the software when you overlay it on the left. We ran, I think we did this one with the Stream C, collected a bunch of scans, and then was able to come back and, you know, identify where there was some tanks here in the little green area you can see. So, but we were also trying to roll out that there wasn't anything else that could have been additional in addition to what we found with our radio detection.
Yeah, and the one here on the right is, well, I can just give them a quick, the one here on the right looks at water intrusion in a road surface. So when you have a bunch of cracks in a roadway, and in engineering, and you probably know this, is the #1 cause of catastrophic failures in roadways is water. So we happened to do this road survey, not specifically for the roadway itself, but it had rained the night before, and this is at NMSU. Is we look, when we were coming across this, I was like, look at this, David, this is very interesting. This is where the water was going through the pavement, and it was intruding into the road base by over 48 inches. And I think we only had maybe 1 inch to 2 inches of rain in this area, which is very rare for this area. But this is what's getting in the roadway and causing the failure. So it was a good case study in terms of being, hey, look at the engineers, look at what water does to road surfaces once it gets on there, and these cracks are not rehabbed or replaced. So it's a good example how GPR can apply to different methods, even when you're not initially using for that. But I thought it was a pretty good capture.
Yeah. So GPR could be the enemy of water could be the enemy of GPR a little bit. But if you're hunting for water or voids, there it is. Well, you'll be able to see it as well. So it's another use for it. Okay. So with this one, it just is, I have augmented reality. So when we had our great data in and great data out, now we have confidence to start using some of these tools like augmented reality, where we can start giving these to the facilities personnel or us or anybody that is interested in this, and we can start to plug this information into augmented reality, and then, you know, putting these tools in the hands of people as it needed. It's going to be a pretty awesome tool moving forward. But if the data is not survey grade data, things aren't going to align where they need to be, and it's just not going to be a good usable tool. It won't be, you know, it won't be using the way it should be. So that's why also, you know, we want to get the data as great as we can, as accurate as we can, because it could be utilized in a platform such as this. So it's pretty cool how it also leads up to augmented reality. And these slides are probably, like, I think there's probably even way smaller goggles than these guys are wearing now. It's just amazing how fast the technology goes. So, but in the end, you know, having this platform, I prefer augmented reality over virtual reality, just because I'll get a little spacey with the virtual reality. But it's a really cool tool. And here's another few slides. You know, you're looking through the virtual reality. You can click on this hydrant. It's got all the metadata associated with it. and it's a pretty cool thing. And then here on the left is just kind of more of a graphic of a tomography slice and how that pipeline might look in there. I'm sure some of you have heard about the Field Link, the Trimble stuff that's coming out, and that's also goes back and forth with BIM and being able to take these platforms to a construction site and doing checks and as-built by leveraging augmented reality and comparing that with models that are built out in the field. We used to do a little, more of BIM coordination projects, and so we got to learn a lot when we were doing those.
So if you get to build it virtually, you basically have taken all the conflicts in terms of the HVAC systems and the footing systems, and you've solved it before it even gets to the point of creating a change order or anything down the line. The greatest thing about that is that you build it virtually, you solved all the issues, but the hardest part of BIM is how do you keep them in compliance to make sure that they're following the system and installing it correctly. So that compliance part of that is a huge thing after you put in all that work.
Yeah. So that's our last slide there. One other thing that's just kind of interesting I'll throw out is through us being able to do utility investigation, it's also brought on people that are interested in subsurface investigating, like historical societies, people hunting for treasure, cemeteries, a little bit of everything. And it's kind of gravitated towards us. I don't think we initially anticipated being involved in some of those things, but we've really, it's kind of become a big part of what we do as well. And John's made some really great connections with some of the historical societies and things down here in southern New Mexico, in El Paso and Columbus. And looking back at history, if you're a history buff, and being able to tie all this together with our subsurface investigation, that really is a beautiful thing. And I've personally learned a lot when it comes to that. It's kind of more of a byproduct. And a lot of that historical stuff is things that, we just really like being a part of. We would do it for free, just because we really love that portion of it. So we were fortunate enough last summer to be part of a production for Beyond Oak Island. It's a show that's on the History Channel. And so we were there working on a production in El Paso, looking for Pancho Villa's gold out there. And a lot of people say, well, I guess you didn't find his gold because you're still sitting here. And I'm like, well, you're going to have to watch the show yourself to find out. But
Episode 2 coming.
Yeah. So it's cool, you follow your curiosity a little bit down a road, and all of a sudden some really cool things start happening as a result. And so we've been pretty fortunate to have that as a byproduct, something that was unexpected, but something that we really, really like. And possibly that could be maybe another topic of discussion at some point. But that's what we have for today. I don't know. Let me see if there was any more chat comments.
Yeah, just a bunch of comments in there. Nothing.
Okay.
A lot of kudos, of course.
Yeah.
Anybody got any questions? Anybody want to unmute themselves, ask questions? Anyone? It's been pretty quiet these last couple during the summer. Go for it, Josh. Oh, Kevin, go for it, Kevin.
Hey guys, thanks. Hey Trent, thanks a lot for this presentation.
Yeah.
A couple of questions. One, how long did it take you guys to become proficient doing this work and kind of being the subject matter experts doing this?
That's I think now we're going on our 6th year of doing this from when we rented that GPR. I'd say it's been around 6 years.
And what's the typical, what is the max depth? I know it's probably a loaded question because you have different types of materials, but what do you guys typically guarantee down to, in a regular maybe?
I would say in an ideal condition, in the best soils known to man, with a little bit of moisture on the top soil to give us some good resolution, you're probably maxing out, that I've seen, probably about 12 feet with the target larger than 12 inches. And I would also say that to become proficient, we've kind of taken off, just ask a bunch of questions and we could give you some good directions in terms of who's in the industry, the players that could get you there, and training and certifications, and we can give you some additional directions and help promote that, because we've kind of already done all that hard diligence and invested a lot of money, and we want to be able to promote this, because now the flip side of that is we have a huge infrastructure bill that they're going to put towards the US. And from the business side, which I'll put my other hat on, is let the surveyors figure out how we can get some of that money in our pocket and be able to not only be the surveyor who's the first person on the site, the last person to leave, but the last person that they ask questions about. Let's be at the forefront with the owners, being able to present these technologies at the same table as the owners, the architects, and the engineers, because that's kind of how we have to position ourselves to be effectively, to be able to make these types of business models work.
Yeah, and I would say you can't go wrong with learning it. It won't be time wasted because it's only going to get bigger. If you do some investigating in your area, you might find out that there's not a lot of people offering the service. And I tell you what, when you can couple it with doing surveying, and you can go out there and not only do the design survey, but also do the utilities and survey them into your own drawing, that's a pretty valuable thing. And we do have clients who really probably benefit from having that under one house. And it is a little bit weird, but like I said, just there's a lot of training. We'll always be happy to share what we can. We know a lot of industry leaders as well. And overall, like I mentioned, our company, we definitely leverage technology. We're learning new stuff all the time. So really, we knew it was going to take some time to learn, but we're used to it because John used to tell me things like, we're going to get a laser scanner. And I used to go, oh my gosh, what? How are we going to afford a laser scanner, John? And then boom, next we have it. Oh, now we got a mobile scanner, right? So it's like, we just gotta take those chances and risks that are smart. And like John said, with your business hat on, you do your research, and I'm pretty sure that you would do really good with offering that service, and with proper training, it's doable. It's not out of the question to be able to learn that. And we're still learning a ton. We learn all the time. I still, we're nowhere near being perfect experts. There's people like Michael Twohig and Geoff Zeiss and these guys that have been doing it even way longer. And we've learned a lot by following them and learning from them and the terminology they use and the language they use. And so, they've been some great resources for us as well. But I would say it won't be wasted. And like John said, if things are turning here, we know at least it seems like there should be money for infrastructure if things kind of take a change in our economy, and you're going to be ready and set up for that.
Thanks a lot for the answers.
Yeah. So, okay.
Did you have more, Kevin? Are you good?
Well, no, I think it's good because we're at the kind of exploration time right now. Also, with GPR, it's just our customers are used to a different level. But as we're taking over, for us, Orange County Public Works, we're taking over John Wayne Airport, so there's going to be a lot of that type of work coming up in the future. So we're just trying to get ourselves kind of ready for what may be coming down the pipe here.
Nice. That's awesome.
Yep. Perfect. Go for it, George.
Okay, this is exactly the type of use of technology that we need to be getting out and showing to high school students, college students, to get them interested in the profession, because there are so many technological tools available now that we're just now, like you say, learning how to use. And that's what kids are interested in today. I'm totally sure of that. And if we can demonstrate to them that there's a wide variety of experience that they can put themselves in and make use of, that's only going to benefit this profession. And boy, I'll tell you what, we need some youth.
Yes.
I'm a classic example of that.
Well, George, I like your way of thinking. And, you know, if everybody was that progressive thinking, we might be a little bit further along as a whole. And maybe we would have adapted GIS a little bit better into surveying and not been scared of the technology. And we're at that time where we need to change that way of thinking. We can't be having tunnel vision and say, well, I only do a boundary survey and you know, a topo or something. No way. Are you kidding me? If you look at the definition of surveying, it's making measurements on the earth, in the world. That could be anything, right?
I'm not sure we want to limit it to making measurements on the earth. I think the universe is ours. We just need to go explore it and make it ours and demand that it is ours. Stake claim to it.
Absolutely, absolutely. And we do have some activities. We have one later this month and then one in July where we're incorporating, it's going to be, one group is with high school students, one group is with middle school students, but it's going to be sort of a geocaching exercise where they're going to walk around the New Mexico State campus looking for survey caps. But a few of them we're going to bury in the grass and the ground, and they're going to have to use the GPR or the metal detector to be able to find it. And there's going to be clues and stuff leading them to this treasure that they're going to find so they can have that experience. So I'm right there with you, George, and we're going to keep doing our best to make sure that we can, you know, share that message.
My wife laughs at me all the time because I'm walking around or crawling around on my hands and knees looking at monuments. It doesn't matter where we go. And I think that's what surveyors do. Oh, look, there's some, what the heck is that? You know, I don't know. And I got into this profession hating history, and oh my God, do I love it now.
Yep, I agree with you.
Well, I think it's a real life skill, to be perfectly honest, because I know my son, I've had, and some other students, I've had them in the summer, you know, probably driving their mom or dad crazy. Hey, look at their survey monument here, you know, and they're looking at you like, are you like crazy? You know, now wait till you get them to look at utility marks. They'll be like, we're walking under a bomb. You know, look at all this network and arteries under here. They're going to be looking, they're not looking up. They're always going to be looking down all the time. That's where they find interesting. And, you know, we find a lot of great things, but it's the awareness in the end that's allowing you to understand just how surveying is in everything. And it reminds us that, you know, it's important for us to be able to be responsible with information and the technology and pass that along. And don't be the guy, don't be the old surveyor. I'm not going to use any names of, you call them up, hey, can I get your AutoCAD or can I get a copy of the unrecorded survey? And he'll look at you like, are you smoking crack? You know, or that, you know, you should feel good about your art piece, your plat map, where you can say, yeah, give it to him. I'll give him my template. I mean, am I doing the disservice to the industry by not giving something I created just to make that better? To me, that's a sense of value, right? You can't have success without value, and that's one way to give it. But I also would be very scared about giving my drawing to a gentleman who still uses a 48GX with an SMI card in there.
It's all about being professional, and we're supposed to work together to solve problems, not create them.
Exactly.
When somebody asked me to share CAD files, you know, my answer is, I got nothing to hide. It's all there. You can have it. You know, that's
right.
Again, right. Making sure those things are, which I preach all the time, but making sure the stuff leaving your office is defendable. And so all the way down to a CAD file, right? So
if you don't share it, how can someone agree with you?
Right.
Right. Right.
Awesome.
That's a good one.
Well, I know it's getting a little late for some of you guys, but anybody else got any other questions?
Thanks, guys.
Yeah, I love it. That was good stuff. Lots of good moving parts in here. So
Great.
If anybody has questions, obviously they can reach out to us. I'll make sure I put you guys in contact and then information and follow-up email as well. But Love
Yeah.
it.
Appreciate it. Thanks
Of
to all
course,
those who
guys.
participated.
Yeah.
Definitely reach out to us anytime. Me or John will be happy to talk with you.
Awesome. Sounds
Yep,
good.
and I believe we have another one coming up on bedrock mapping. So if you're interested on taking
Yeah.
GPR to the next level, that's going to be an interesting one that we've also presented at a GPR conference, which we can get you additional information if you want to get plugged in with some PhD GPR professionals in academia.
Yeah, that'd be cool. That'd be awesome.
Okay,
Okay.
great.
All right. Have a good
All
night, guys.
right. Talk
Take
to you
care.
later. Have a good evening.
Yep. Bye, guys.
Bye-bye.